Hey, welcome to Ones and Zeros. My name's Ben, and today we are looking at episode 8 of our Unearthing C++ series. In this episode, we're going to be taking a look at enums and what they are, how we use them, and why we would use them. They're incredibly useful. If you've seen any of the videos I do in, say, my STM32 Basics series or Discovering STM32, then you might have seen me use them quite often. There's probably not an episode of either of those two series where I haven't used enums for one thing or another. And essentially what they're used for is for allowing us to select between, say, two or more different options for a particular thing. So if we jump over to our code, basically just got Visual Studio up and running with a simple console application like we've done for a bunch of the previous episodes. Just got our main function, just got cin.get to get it to wait for us to hit enter before it continues, and just including IOStream in here so that we can print stuff out to the console. So imagine that we have a function somewhere else in our code, which we'll just call select option, and that requires a, say, one of three different values in order for it to do what it needs to do. So let's just go with a bit of pseudo code here to help explain this at the moment. So in this particular instance of this function, it wants a value that's either 0, which will give us option A, a 1, which will give us option B, or a 6, which would give us option C. So it could be something that it's got to put in, say, a hardware register on a microcontroller, or a specific API for something that requires a very specific value or something like that. And any other value that we pass it may get it to do something that's not defined. So we need to make sure that we're passing it a value that is either 0, 1, or 6, because anything else may cause it to do something we don't want it to do. So in this case, we could, in our main, just have, say, a uint8t, and let's call this option, and we'll put a 0 in there. And then we go to call our actual method, and we can just pass it that variable. Let's rename it so that I don't like the way that was named. So let's just pass it that particular value. Now, in here, there's nothing actually checking to see whether or not what we're passing to that function is essentially a valid value. So there may end up being a bit of code in here. Again, just as a rough example, that adds 10 to that, and then we end up with option equaling 0 plus 10, which is 10, and then getting passed to this function, which is then going to mean that it's getting passed a value that is effectively invalid and causes it to go off and do something we don't want. So we could, from a programmatical perspective, check to make sure in here that, again, it's probably not going to be the most well optimized code, but it's more to demonstrate the reason for using an enum in this case. So we'll go through and in our code just get it to check whether it's an invalid value. let's, in that case, get it to just pop out a message saying to us that it's detected that the value is invalid. However, if it is a valid value, then I'll just fix up these as well. All right. So it goes through and it checks. If it's not one of the three values that we want, then it's going to let us know that, well, the particular option is invalid. Otherwise, it lets us know it's valid, and then it knows that it's basically all good to be able to go through and run our select option function at that point. Might even just pop some end lines in there just to be a little bit neat. All right. Now we could go through and do this programmatically. We might need to call this function at various points in our code, various different places, and at each of those places we would need to go through and check whether or not we're actually providing a correct option. There is a simpler way to do this. We could, as a example, we could go through and make some defines for the particular options. So we could go option A is 0, option B is 1, and option C is 6. And then we could make sure that we are only using those particular defines in here. So like so. However, that doesn't get us around the fact that we could potentially have a situation where our variable here has had something happen to it like this that's then going to cause it to be invalid, which means we'd potentially still need to go through and actually check whether the option contains a valid value. So that could work, but it relies on the programmer to do the right thing. And we would like a situation where we can actually get the compiler to help us with that and basically not allow a situation where that value is not going to be what we want it to be. So what we can do is go through and we'll delete our defines. We'll create an enum. And let's call it valid options. And in here, we can go through and make valid option A, valid option B, and valid option C. Now, with each of these options, if we leave them like this, then the way the compiler is going to go through and number them is the first one is going to be 0, the next one will be 1, and the next one will be 2. And they'll follow on in the list in that particular increasing order like that. We can also go through and set the particular values, which we're likely going to want to do in this situation, because we know that option C should be 6 rather than 2. So we could actually just go through and tell it that option C equals 6. We don't really need to go through and set option A and option B here to particular values, because the compiler is going to make those 0 and 1 anyway, because it's going to start from 0 and then B is going to be the next one, so it'll add 1 to that, which would make those correct. Generally, when I'm writing an enum for the very first one, just so that I've got a visual reference, I like to make sure that I'm putting the particular starting value in there for that one. In this situation, because we've got 3 options that are not necessarily going in ascending order because of it going 0, 1, then 6, I would most preferentially put in =1 for the second option as well. Simply, again, so that when I look at that straight away, I can see what each option represents in terms of a specific value. Now, the other thing that we can do is we can define what type the enum represents as well. So in order to do that, we know that this function that's hidden elsewhere in the code that we want to be able to access requires a uint8 for its particular option. So we can just go colon uint8t there, which then tells the compiler that the values in the enum are values of that type. So I also like to do that in my code, so whether it's going to be an unsigned or signed integer, whatever bit length it's going to have, you could just use a normal int in there if you wanted to, that's fine. Typically, as far as I remember off the top of my head, if you don't specify the type that the enum is, then it should just fall back to just a standard integer. But in this case, because we know that that's what this requires for this function, that's what we'll actually create here. We might actually move this enum down a bit to help us represent the fact that that select option function is somewhere else in the code in another file or something like that. Now, this then allows us to, rather than having our option here when we declare the variable declared as a uint8t, and delete that guy, and we're going to change it to the name of the enum so that this variable is now uses the data type of the enum itself. Now change that to an E at the start of the name, just because that again is a naming convention I use to let me know that that's an enum rather than say an unsigned integer, which it was. Now straight away, if we try to put a 0 in there to set it to 0, which is a valid option for what we're trying to do, we're going to get an error from the compiler because we can't just assign a value to it because it's an actual enum. So what we need to do in this situation is go say valid option A, which it should be happy with, or B, or C, and it'll be happy with all of those because they're valid members of the actual enum that we're using for this variable. So straight away, the compiler is already doing a check to make sure that the value that we're putting in there is valid. It also then prevents a situation where we then try and go through and do this at some point in our code where we're messing up that particular option, because it's basically saying this is an enum. You can't just go through and actually start messing with it like that. You can create user-defined operators, which we might look at in a future video. But in this case, the compiler has also checked here and said that what we're doing here is not right. So in that case, let's just comment that out. That's saved that particular problem straight away. Now, we could go through and still do our check to check whether or not it is a valid option, and this would actually still work. But because the compiler is already checking that we're supplying a valid option here because of the enum, we don't actually need to programmatically go through and actually check whether or not that's a valid value because the compiler is doing it for us. So we've just saved ourselves, even if it's only a couple of clock cycles, that's still a couple of clock cycles, but we've also saved ourselves having to write the code, which is also beneficial. So that is why we might use an enum. So in a situation, say working with microcontrollers where a particular register might require one of a set of particular values, or we've got to select from one of a set of particular options, we can allow the compiler to take on the role of checking that what we're doing is correct in a situation where otherwise we could potentially cause undefined behavior. So really, really useful for that, and allows you to let the compiler look after some things so that you can then focus on other stuff that's kind of more important. And there's kind of the perfect example of that, where we've just managed to get rid of having to programmatically check something because of the fact that the compiler can now sit there and do it for us. So I hope that makes sense. If you do run into any questions about any of this stuff, feel free to leave a comment in the section below the video. You can also jump over to that corner, to our subreddit, or send me an email if you've got any comments or feedback or questions, anything like that. But I find that any time where I've got to select between a set of options, I'll use an enum just because it tends to be safer. The compiler is checking stuff for me rather than me having to double check as much. Still good to double check your code, definitely. But it prevents you from being able to end up in certain situations where you might end up with undefined behavior that you've then got to go through and debug. That could have been solved by using an enum and having the compiler double check that for you. So hope you found that useful. If you enjoyed the video, would love it if you popped a like. If you haven't subscribed, would love it if you subscribe to the channel. There'll be plenty of really cool content coming out across all of the different video series we've got happening at the moment, as well as some new series which is looking at being launched soon. A big thank you to all of the people that have been watching and those that have liked and subscribed and left awesome comments. I really love all of that. And a huge thank you to our patrons as well. It's awesome that you're helping to support the channel. A huge thank you for that. And hope you enjoyed. Thanks very much for watching.